So this is our last video for A3, and we're going to be talking about the feature of function called average rate of change. So the average rate of change of a function is the slope of the line that connects 2 points on that function. So basically on the last question, I'm going to talk a little bit more about what it really means. For here, you can just think average rate of change is slope, right? Which we have a nice formula for here. Usually when you have an average rate of change problem, they're going to give you the x values. So they'll say use these two x values, and then you have to use either a table, an equation, or a graph to get the y values, and then you do slope. And I think in ninth grade, they're basically just like average rate of change is slope. It's almost slope. That's how we find it, but we'll talk more about it in a second. So first off, just as a reminder, this is your slope formula, and your 2 points to plug in are x1, x1, y1, and x2, y2. So those get plugged into these spots in the formula. You're basically doing rise over run. How much does the y change divided by how much the x changes? So in our first question, the easiest way to do this is with a table. It says, given the function defined in the table below, find the average rate of change in simplest form of the function over the interval 1 is less than or equal to x is less than or equal to 3. So here, those are my x values. So I always write my points down. So I want an x value of 1, and I want an x value of 3. So I'm going to go in my table and find the corresponding y values that go with those x values. Once I get here, I'm just going to do the slope formula. So I have y, and we'll label them. I do not take the time to do this usually, but just so we're clear. First x, first y. Second x, second y. So y2 minus y1 over x2 minus x1 is 135 minus 15 over 3 minus 1. So I can type this entirely in my calculator. That's probably the easiest if you have a graphing calculator. If you don't, you might want to top in the numerator and denominator separately so you don't have to worry about parentheses. But this does simplify to 120 over 2, which equals 60. So that's how you do that with a table. The next page. Here we have with an equation. So basically, we use the equation to get a table. So we're going to go into the Desmos calculator, and it will actually make a table for us. So now that I'm in, I'm going to start typing in that function, which is x squared minus 6x plus 6. And then if I go over here to graph settings, I am going to look for the table, though I might not be in the right spot. So let's click over here. Settings. Yes. Okay, so I found it. So press settings up here. I think I wrote that down for you, but then I didn't read my notes. This is new for me, this calculator, because we don't have the graphing calculators at home. And I press table. So what's kind of cool with this is it gives you a basic table, but you can also type numbers you want. So you could type a 2 here, and you could type an 8, because those are the two numbers I want. So I have 2, -2, and 8, 22. So that's a really nice, I don't know if I want to type 100, it'll calculate that for me, really whatever I want. So you're in a lot of control of your table. So let's write down those 2 points. So they gave me the 2, and we found -2. And then they gave me, and when I say they gave me, I mean those are the numbers they gave me, the 8, and then I get 22. So when I set this up, I have 22 minus -2 over 8 minus 2. So that's just my y2 minus y1 over x2 minus x1. This simplifies. I'm just going to show you an extra step since I didn't do this the other time. That's 24 over 6, which does equal 4. So that's my answer. So I want to actually go back to the Desmos calculator because I realized my directions here. Let's just close this out. type our function back in. They're slightly different, so they might have changed the calculator since I made the packet. So to convert it to a table, we're just going to click on this gear, okay, and that's going to pop this up, and then right here is convert to table. So it's gear and then this button to get your table, as we did before. So let's move over to the last question. Here's our function, and this one's on a graph, okay? So here we actually have to circle the points and figure out what goes with them. So we want to look at the point associated with -6 and the point associated with an x value of 3. So I'm going to circle those on the graph. It's kind of hard to see here because the graph doesn't copy great, but on Delta Math, you guys will be fine. So it looks like -5 goes with the -6 for the y, and then -25 goes with 3. So as I said in the last question, I'm going to talk a little bit more about average rate of change. So if I draw a line between those 2 points, I can see that that red line is not my graph. So when we're saying it's the slope of the function, it's not really the slope of the function. It's called the slope of the secant line. And if you remember from circles last year in geometry, a secant line is just something that cuts through a shape. So I'm finding the slope of this line that connects them. I'm not actually finding the slope of all these little points, right, that are along here, because the slope of this graph is always changing. That's important, as I said, when you get to calculus, just to kind of think about, well, what's happening here? How could I really get the slopes of all those little blue points? That's something that you'll do later if you move on in math. So let's just set up our slope formula. So y2 minus y1 over x2 minus x1. So when I simplify this one, it actually doesn't reduce. It's going to stay as a fraction. So the top is 20. Okay, so -25, you end up +5. Sorry, -20. And the bottom, 3 plus 6 is 9. On Delta Math, when you enter fractions, if this hasn't come up yet, you can just type that like backslash button, and it will come up as a division sign. Okay, actually forward slash or backslash. Can't think of it right now, but try them both. Basically the one that goes like this. Okay, so that's how you can type it in. It'll pop it right up to a fraction, and you guys can type in the answer that way. Okay, so basically here it says after you complete the entire video, we ended up embedding these videos. So it's like video questions. So you can kind of ignore that last line. It's pretty self-explanatory on the Delta Math.